Hello people, my teammate Jeronimo Sanchez and I, Irem project is porting and benchmarking on a fully ARM-based cluster with EPCC called Fulham. We aim to explore the limits of Fulham. This is a relatively new cluster, and while some codes and libraries are already ported and optimized, there is a lot of work to do in porting, optimizing, and understanding the strong and weak points of the system compared to other clusters. Fulham is named after Elizabeth Fulham, a Scottish chemist who invented catalysis. It is part of the Catalyst project, and it's one of the 3 similar clusters based in the UK. It is designed to explore usage of ARM ISA in production of HPC systems rather than x86 ISA. It's a 64-node fully homogeneous R64 cluster based on Thunder X2 chip from Marvell. Jeronimo and I chose different ways to explore and enhance Fulham. My approach was to test its limits with Firestarter, an open-source processor stress testing tool. Basically, I was trying to make the cluster as hot as possible, literally, by adding, converting, and changing Firestarter code. Processor stress test utilities are important tools for a number of different use cases. To test cooling systems at maximum load, or for fulfilling the prerequisites of energy efficiency research by measuring idle and maximum power consumption. Fulham needed a simple yet versatile tool that generated near peak power consumption of its compute nodes, and Firestarter was perfect for it, because it was specifically designed to do just that, thanks to the code being written in highly optimized assembly routines, and they are specified according to Fulham's microarchitecture. Initially, Firestarter was written for x86-based systems. However, Fulham is ARM-based. That meant decoding the whole project from its x86 instructions and encoding it to R64 instructions just to make it run properly on the cluster. ARM CPU instructions are reasonably atomic, and that leads to less power consumption. Which is why ARM is more popular with mobile ecosystems. There aren't many ARM-based clusters, and Fulham is dedicated to explore that. There isn't an exact conversion between x86 and ARM registers and operations, so there was a lot of guesswork involved, but we hoped for the best, and good results came out. In the end, the resulting code flow in ARM language really stressed Fulham out, as we intended it to do.
When an operating system is running under an ARM processor, the CPU doesn't get displayed correctly regarding its core and thread numbering, as on an Intel or a x86 CPU. This issue makes OpenMPI to select wrong threads when the simultaneous multithreading of the machine is greater than 2. As displayed in the comparative examples running under simultaneous multithreading 4, the Intel format has unique core between CPU sockets, and each thread is numbered in ascending order from the first core. In ARM, each socket has 4 threads, having each one of them 32 variants. In the end, each machine has 256 threads, but the numbering is quite different. An example of this behavior is presented in the following slides. At the top right corner, a program is pinned on the thread 0, 1, 2, 128, 129, and 130. When this program is executed, as is displayed at the bottom red rectangle, the thread in which the program has been pinned are wrong. On the other hand, when the program is pinned into wrong threads, the output shows that the program was pinned into the thread we originally wanted. Using the newly created CLI tool, the threads in which a program is wanted to be pinned into can be introduced, and the output of said tool is a OMPI command to run the program on said threads. As is shown, the program xthi is pinned into the thread 20, 33, 36, and 60, but the output of the program says that it was run on the thread 5, 9, 15, and 40, the same threads introduced in the CLI tool before. IOR is a utility that measures the performance of a system regarding its storage accesses. The output file format has a heading with information about the own system and a section with the results of the storage accesses. Using the CLI tool created over a set of IOR files, the utility outputs an Excel report about the performance, showing a comparative chart.
It is Wednesday, my It is Wednesday.